Hey guys, so today you and I are going to talk about elegance and cleverness. So let's get into it. So the question in question was, hi Frederick, what is the difference between trying to be elegant and trying to be clever when you write code? Well, there is some overlap, I would say, with the two, but I would define being clever as more about having a solution to a problem that might be a challenge for you to solve, and do so in a nice way, come up with a good, nice solution for a more sophisticated problem, whereas elegant code is more a simple solution to an ugly problem, if that makes sense, where one is more focused about solving a problem in a complicated problem. One is more about solving things in a very simple creating a simple and easy to follow implementation of almost any given problem. To give you a few concrete examples of an elegant solution versus a clever solution. So I have a pattern that I like to follow when I work as with testing, for example. Whereas where like one of the problems that you have when you do something, say, as integration tests, is that whenever you are running the test, you usually need to build up an existing database state to do some test. You basically need to create data in the database in order to execute your test in an effective manner. And so the way that I actually have a video about this, if you want, I think it's called like the builder pattern or something like that. Now my argument is that that is an elegant solution. The reason why I argue that that is an elegant solution, I know that this gets very semantical, is that the problem is not a complicated one. You can, in many different ways, create the database states. You can write like direct queries and push that to the database, so you can create like utility functions or this and that, and like there's many ways of solving that problem. The reason why I argue that the builder pattern in this case is a nice approach to this is because the way that you implement a builder is basically that you chain different operations on top of each other and then you execute. And that basically is what I do with that, like my builder, where I create queries that will create do an operation such as create a user, create a product, create a order, connect the user and the product to the order, etc. And then like you run that as an execution, and then it returns like the entities it has created for me, and that basically becomes like you can almost think of it as a programmatic CLI, where you can control and tweak the operations that you need in order to build up that database state. It's like a raw, you never use it in production, of course, you just use it in a test. And so you can concatenate, you can basically compose the exact state that you want in a fairly efficient way without having to do a lot of duplications. It's just you use the same function over and over, and then you can pass in override properties, such as if you want the user to have a certain name or the product should have a certain ID, or things like that, into the methods on the builder. And so that creates a very clean and simplistic solution to a problem that could be very messy. It's similar to how I have another pattern that I follow that I argue is fairly clean, if that makes sense, or like it's not clever, it's just clean, where a lot of people create when we run unit test again, we create a lot of mock data. And the way that people usually do that is that they create utility functions within the files that they have, or they create a lot of I've seen this every single time I've worked on a project, where sooner or later you're going to find yourself needing to mock some data. And people always do it in different ways. You do it like you like copy paste a JSON response from like a network or something, or you fill it out with some fake data or so forth. There's never any consistency in that, and that feels ugly to a lot of people when things feel a little bit ad hoc. So what I usually do is that I create a a factory function where it's a higher order function which acts as a factory, where you pass in a like the JSON that you want. So you basically create a little folder where you put the data that you're gonna stub and fake, so you can take an entire response from like, you know, a network call, which is really large. You don't want to put that directly in your code. So you can put that into a file, and then you feed that data into the builder function that returns a function that you can use now to override specific properties, which basically does the same thing as I was saying with the builder, where you can create a new instance of the data, and you can override all the default properties you set at the first time, and then you can override them as you wish. Once again, it's not necessary. Well, you can make an argument for that being clever, because it could in theory be a difficult thing for you to figure out how to deal with this problem, but I will argue that it's more on the clean side. When it comes to being clever, it's a little bit more difficult to describe it. So for me, as I was saying, being clever has more to do with that you have a very complicated problem and you need a clean and efficient way of solving that problem. So if we take an example that makes things like a clever solution to a problem that I've had, I argue, is that we've had an issue with creating like shipping components, for example. I was working in a project that was dealing mostly with React. And so the problem we had was that we wanted to test out components in production before we shipped them to production, basically, because we didn't trust that our QA environments and so forth were like up to snuff. And so what I did was that I created a component called a feature toggle component, and all that component did was to read from local storage and check whether or not a specific parameter was set or not. And it would render the child components only if that property was set, otherwise it would not. And that, I will argue, is a decently clever solution, because that basically means that you can ship your React, like the entire node tree, to production, enable a local storage parameter. It doesn't have to be, it could be anything basically, and then check the results in your browser, try it out in production, it's just affecting you, and then basically remove the flag. And when it was time to ship the component for real, you could ship the component for real. That would be an example of a clever solution, because many times you want to check things in production before you actually check them. That's basic. It's a basic feature flag. It took like just a few minutes to implement that. Another example of a quote-unquote clever solution would have been that we have there was a requirement for us to add in this case it was an error boundary around a bunch of different components that and we had a set of specific components that were at this, as we call them, top level of the node tree. And this is also in React. And the problem with that is that when you have to add an error boundary around a component, you sort of have to remember that you should be doing that, because the difficulty in that is that basically you have to make sure that people remember to do something or use a specific component for a given job, and that is very difficult because people always forget things such as adding everything from adding unit tests or adding error boundaries or adding logging or things like that. So what I did, or like what we did, was basically that we sat down and wrote a custom linting rule for checking for that exact thing. Basically, we wrote a custom implementation of an ESLint rule that checked that if you were touching any of these components, that it actually had this wrapping error boundary around it. And we've had other examples where I've written a linter that actually tells you if you're using the right import or the wrong import. For, say, a classic one is everybody imports too much stuff into, in this case it's Node.js, right, or in JavaScript, right. And then you can actually specify a blacklisting saying that you're not allowed to, say, import the entire Lodash library or the entire Material UI or whatever you're using. You have to use a specific syntax to actually do that. I've also done things such as create custom errors because we had problems with consistent error messages, so I created a custom error, and then we created a lint rule that would say you ban the usage of the base error class in JavaScript. In this case, I mean, it will work in any language, and you're only supposed to use errors from this specific category, these custom errors that enforces a much more descriptive and well-structured error message. So what I want you to take away from this is that clever versus clean, it's difficult to define. I usually define it as clever is more about a smart solution to a complicated problem. Clean is an elegant solution where it's very simple to work with your solution. And so in my example, clean would be a very easy and efficient way to write, say, unit testing or mock code or implement logic like that without a lot of issues with duplication or issues with inconsistency. It doesn't really create like a messy code base, if that makes sense. It keeps things quote-unquote clean. Whereas clever is more about a complicated problem that most people struggle with in some fashion, and coming up with a simple solution that makes that problem sort of disappear. It mitigates a lot of the impact. That's the argument I would make. Have a great day.